All right, welcome to 11.4. 11.4's title is two-way tables. These are probably going to appear in your EOC, so I wanted to get these in before we moved on to the review. So let's just talk about what a two-way table is, okay? A two-way table is a frequency table. So it's how often something occurs. So it's a frequency table that displays data, which is good. That displays data collected. I don't know why my lines ended like that. Displays data collected from one source that belong to two or more different categories. Okay? So what this means is that you ask somebody something, or you ask them two things. So like if we were to take a survey in the class and ask them how many pets they own, we could look at a couple different things. We could look at, their gender and then how many pets they own, or we could look at their age and how many pets they own. Okay, so you're going to basically be looking at two different kinds of data at once. Okay, so the easiest way for me to talk about this is to just show you an example. So here's example one. It says the two-way table below shows the results of a survey that asked freshmen and sophomores whether they access the internet using a mobile device. Okay. And so we want to find and interpret the marginal frequencies, okay? The marginal frequencies, that's just a really fancy word for total, okay? So we asked the freshmen and sophomores if they had mobile access on their phones. Basically, do you have internet on your phone, okay? So 55 freshmen said yes, 22 freshmen said no. 63 sophomores said yes, 12 sophomores said no. So what that means, if we total these rows, 55 plus 22 is 77. That means that there were 77 total freshmen asked. That's what that means. There were 77 freshmen asked. And similarly, if we did the same thing to the sophomores, 63 plus 12 gives you 75. So that means that was the total number of sophomores we asked. Okay? So, in the same realm, if we add the columns, we have 55 plus 63, okay? There were 118, so that's the number of people, freshmen and sophomores, but here just people, number of people that have internet access on their phone, okay? And then 22 plus 12 gives you 34. So this is the number of people that don't have internet access on their phone. So then if we total either this column or this row, it should be the same amount. 118 plus 34 is 152. And just to make sure, if you do 77 plus 75, that's also 152. So that represents the total number of people who were surveyed. Okay? That's basically what we're looking at. So when it says find and interpret the marginal frequencies, these are your marginal frequencies. They're just your total, your row, or your column totals. Okay? Nothing super fancy, just an interesting way to display data. Okay? So here we go. This is example 2. Okay? The two-way table shows the results of a survey that asked college-bound high school students whether they plan to major in the medical field. Okay, so we're going to fill in and figure this out. So we asked juniors and seniors. 124 juniors said yes and 219 said no. 101 seniors said yes, 236 said no. Okay, So let's go ahead and find our marginal frequencies. So 124 plus 219 is 343, and this is the total number of juniors asked. Okay, and 101 plus 236 is 337. So this is the total number of seniors we asked. And then if we do 124 plus 101, that's 225. That's the number of people majoring in the medical field. Sorry, I didn't give you a lot of room to write. And then here, 219 plus 236, 455. This is the number of people not majoring in the medical field. So something else. We don't know what it is. We just know it's not the medical field. Okay, so then if we take that number and we add 225, we get 680. So that is the total number of students asked. So we asked 680 people. Okay, so that's the same thing we just did. Now what we're going to do is we're going to take this table and we're going to ask you questions about the data. Okay? So A, that was part A. Part B says, given that a student is not planning to major in the medical field, so we're looking at all the students that are not majoring in the medical field. That's this number right here. What is the likelihood that he or she is a junior? So 455 is the pool that we're looking at. We want to know how many of those is a junior. So 219. So out of all of the ones not majoring, how many of them are juniors? So we take 219 divided by 455, and your calculator spits out approximately 0.481, which is about a 48.1% chance. That means that if we were to ask all of the people that said no, there's a 48% chance that they're a junior. That's what that means, which would make sense, right? I would hope that you asked, half of the juniors, half of the seniors. So similarly, given that a student is a senior, so we have 337 seniors, that's the pool that we're looking at, that's our big pot. What is the likelihood that he or she is planning to major in the medical field? Well, we have 101 of them that are planning to major in the medical field. So we do 101 divided by 337, and that gives us approximately 0.2997, which is about a 29.97 or 30% chance. So what that means is that if we would ask a random senior, there's a 30% chance that they're going to major in the medical field. That's what you just found, okay? Given that a student is planning on majoring in the medical field, so we know that the answer is yes, so that's the big pool, 225. What is the likelihood that he or she is a senior? Well, we've got 101 of those. So we do 101 divided by 225, and we get about 0.449. So there's a 44.9% chance that if you're majoring in the medical field, you're probably a senior. Okay. All right. This one's interesting. Hold up. Let's just talk for a minute. Let's talk about the difference between C and D. So some people like to argue with me that C and D are telling me the same thing. They're not. Okay. Given the student is a senior, what is the likelihood that she or planning is majoring in the medical field? There was a 30% chance that happened. But then I switched them and I said, given the student is planning on majoring in the medical field, what is the likelihood that he or she is a senior? Those are two different questions, you guys. Okay, the first is asking you, you are a senior, so what's the likelihood that you're planning to major in the medical field? And the second one's asking, you're planning on majoring in the medical field, so what's the likelihood that you're a senior? They're two different questions. They're not the same question, so just keep that in mind. Okay. E, given that a random student is surveyed, so now we're talking about everybody. Out of all the people that were surveyed, what is the likelihood that he or she is a senior? Well, we've got 225 seniors. No, lies. 337. Okay, so there are 337 seniors out of everybody. So 337 divided by 680 gives you about 0.496 or a 49.6% chance. So if you ask anybody in the room, there's a 49.6% chance that that person is a senior. Okay. A couple more here. I'm going to keep this table though because we're going to need it for these next two. Given that a random student is surveyed, so again, we're talking about all of them, what is the likelihood that he or she is not majoring in the medical field? So we've got 455 no's. So if we ask anybody in this group of people, okay, that's about 0.669 or a 66.9% chance that that person's going to say no. So if you ask anybody in the room, are you majoring in the medical field? There's a 66.9% chance that their answer is going to be no. Okay. Given that a student is not planning on majoring in the medical field, so 455, what is the likelihood that he or she is a senior? There's 236 of them. So 455, nope, lies. 236 divided by 455. And we get approximately 0.519. So there's a 51.9% chance that if you're not majoring in the medical field, you're a senior. Okay. Those are called the conditional frequencies, by the way. Conditional just means if something. So if you see the word if or given that, it means conditional. So you might see these as the conditional marginal frequencies as well. That just is a word that might even pop up. Okay. So at least gives us a start on two-way tables. We'll talk some more in class and have some work time there. Okay.